Hi, good morning. The topic today we are going to discuss about is advanced queuing models, type 3 problems in probability and queuing theory. Before we go for queuing model, we have to know the representation for queuing theory that is given by Kendall. So the representation is A slash B slash C and D slash E, where A is inter-arrival distribution, B is service time distribution, C is number of channels or servers, D stands for system capacity, and E stands for queue discipline. In advanced queuing models, we have three types. First two types problems we have seen already. Now we are going to see the type 3 problem. That model for type 3 is MEK1 infinity first in first out, where M is the arrival time which follows Poisson distribution. EK is the service time that follows Erlang distribution with K phases, with single server, infinite capacity, with queue discipline as first in, first out. We go for the formula for type 3. Type 3 is MEK1 infinity first in, first out, where EK is the service time following Erlang distribution with K phases. So, in PK formula, we substitute sigma square as 1 by K mu square. Then, the PK formula becomes L is equal to rho plus K plus 1 by 2K into lambda square by mu into mu minus lambda, where rho is always lambda by mu. Then the next three terms LQ, WS and WQ are the same for all the three types. Only the LS formula alone changes. Then in type 3, we are going to calculate another one, that is mode. Mode is the most probable time spent in the service, and that is given by the formula K minus 1 by mu K. Now we go for the problem. We have a problem stating that a hospital clinic has a doctor examining every patient for a general checkup. On an average, the doctor takes 4 minutes in each phase of checkup. Although the distribution of time spent in each phase is exponential, if the patient goes through 4 phases in checkup and arrival of the patient to the doctor's service as Poisson distribution at an average rate of 3 per hour, find first subdivision is what is the average waiting time spent by the patient. Second subdivision is determine the expected number of patients in the system. Third subdivision is what is the average time spent in the examination. Fourth subdivision is what is the most probable time spent in the examination. So given here we have 4 phases and the patient must go through all the 4 phases. So K equal to 4, and the given problem is third model, that is MEK1 infinity first in first out. Number of phases K equal to 4. Lambda as the mean arrival rate, given as the patients arrive at an average rate of 3 per hour. So lambda is 3 per hour. Then we have to calculate the mean service rate mu, that is given the doctor takes 4 minutes in each phase of checkup. So service time in each phase is 4 minutes. that is mean service time as 4 into 4 because service time in each phase is 4 minutes and we have 4 phases. So 4 into 4 is 16 minutes. Now mean service time is 16 minutes. We need mean service rate, that is mu, inverse of mean service time. So it is 1 by 16 per minute. But lambda is per hour. So we convert mu as hour. So 1 by 16 into 60, that is 3.75 per hour. Then we calculate first rho. The value of rho is 3 by 3.75. Now we substitute rho as 3 by 3.75 and K as 4 in the pK formula for LS. So we get LS as 2.8 customers. That is rho value is 3 by 3.75, K is 4, lambda is 3, mu is 3.75. So we substitute all the terms and we get LS as 2.8 customers. Now LQ. The formula for LQ is given by LS minus lambda by mu. LS is 2.8. Lambda by mu is 3 by 3.75. When we calculate, we get LQ as 2. Then WS is 1 by lambda into LS. Lambda is 3. So 1 by 3 into 2.8 is 0.933 hour. Then WQ is 1 by lambda into LQ, that is 1 by 3 into 2 equal to 0.667 hour. Now, what are all the subdivision asked? First subdivision is the average waiting time spent by a patient, that is given by WQ, that is waiting time of a customer in a queue. WQ is 0.667 hour. Second subdivision is the expected number of patients in the system, that is given by LS 2.8 customers. Third subdivision is the average time spent in the examination, that is WS minus WQ. When we subtract both the WS and WQ, we get 0.266 hour. The last subdivision is the most probable time spent in the examination, that is given by mode. Mode is 0.2 hour.